PTC for a session on design and source for sustainability with aPriori. But let's start first with a quick introduction by me. My name is Torbjörn Peterson, and I'm the Alliance Manager for PTC, leading these webinars where we invite customers and partners for some inspiration on digital transformation to see what is possible and how to make things happen. And we are running all these webinars on Friday, same time, with topics around either manufacturing, services, or engineering. And all the recordings of the past sessions are also to be found on the registration site. The agenda for today is first a quick overview of PTC by me, and then Mark and Paul will run the show, but they will touch base on a few challenges, how to address these, and then also explain some of the business outcomes. At the end, we're also having a Q&A session, so please keep your questions to the end, or you may also put them in the chat. We will pick them up during the Q&A. Next slide, Mark. So just a very quick overview about PTC for those who don't know us. PTC is a global software company with a headquarters in Boston, and we provide market-leading solutions on IoT, augmented reality, PLM, CAD, service lifecycle management, and ALM through the digital thread to help companies to accelerate their digital transformation. So now over to you, Mark.
Thanks very much. Thanks for having me and representing aPriori here today. So today's session is all about sustainable design and sourcing. So before we get started, it'd be really useful to know who we've got attending today. So what job roles, what's your responsibility, just to get an idea of the split across different roles. So if you could just answer the poll on the screen, that would help quite a lot. But essentially, why are we talking about sustainable design? Well, it follows on from Dave Duncan's PTC talk last week, which was really good, talking about his tour of Europe and talking to different customers. And we've been through a very similar journey with our customers. The reason why climate change is obviously a big concern, and doing the right thing, part of that is what we can do. And as product manufacturers and product designers, we have a part to play there. Manufacturing as an industry plays a huge part, big percentage of greenhouse gases and overall energy use. Then there's customer demand, closely linked to what's going on with climate change. Customers are preferring more sustainable products. They're wanting it. OEMs know that their customers want it, so they're demanding their suppliers to be more sustainable as well. You read some reports, they're willing to pay more for sustainable products, but they're certainly putting their money, the wallet share is going towards more sustainable products. And investors are recognizing this as well. More sustainable companies offer less risk, and investors want companies to be more sustainable as well. So all of these pressures are heading in the right direction to make more sustainable products and design them more sustainably. And if those first three weren't enough, then we've got the law behind it. So lots of legislation and regulation coming in, both in the EU and the US and in the UK, all about reporting and very much focused on carbon emissions for the time being. But everything's pushing manufacturers and product designers to be more sustainable. So can we just look at the results of the poll just to see who's in today's session?
You should be able to see them, right, in the chat and clicking on view results. But we have, if I can comment, there is 64% of our people of the audience who are from design, 18% from manufacturing, and 18% from other.
Great. Okay, thanks very much. Okay, so from talking with our customers, we've identified a number of different levels of maturity when it comes to product sustainability. So not really talking about corporate level reporting, how much renewable energy we're using for our offices and things like that. We're really looking at it from a product level, because that's, as product designers and manufacturers, that's where we have the most influence. So if we could just look at the second poll, what stage would you say you're at when it comes to product level sustainability? That would be good to get a sense in the poll. And what we found is these 4 levels. So just while you're answering those questions, the poll question, I'll run through this slide. So the first level is really to establish a baseline. So in order to improve our sustainability, we need to have some kind of measure. So we need to start somewhere and establishing a baseline, usually picking a year or a particular range of products, and establish a baseline. So that's what we need to do. We need to figure out how we're going to measure it, get all the right tools in place, and create that baseline for carbon emissions or embodied carbon. And then the second area where companies have got the baseline, they're looking to make some improvements. They look at it from a sourcing perspective, because that's really the easiest place to start. We can kind of put pressure on our suppliers, and look for more sustainable regions of the world to get products made. So if you're looking at the Nordics, for example, there's lots of wind power in that region. If you look to Brazil, there's lots of hydroelectricity, things like that. So lower carbon emission electricity areas of the world is a good place to look. But then it gets a little bit complicated, because like the Nordics, probably going to be a more expensive place to source it from. So you've got to balance the two all the time, because if your product ends up being too expensive, no one's going to buy it. And then it doesn't matter if it's the most sustainable product in the world. If it's staying on the shelf, it's not doing anybody any favors. So that's the easy one. You're not having to change the design. You're just looking at different places to manufacture it. Then the third level, we call it kind of sustainable value engineering or re-engineering. And it's essentially looking at existing products, making some small changes to it, maybe looking at more recycled content in the material. So we're not really changing the design. We're looking at different materials, keeping the design pretty much the same. Maybe we can use the same design and use a different process. Depends on the design, obviously. But just look at kind of re-engineering it to be the same kind of product, but with a lower carbon footprint. And then the last stage is really starting with sustainability in mind. So when we design the product, we're looking at the most sustainable places to get it made. We're looking at the most sustainable materials and the most sustainable processes to use as well. So all in combination, really taking a holistic approach. So what have we got in the poll for how mature people are and where they are on their journey? We got some results there.
Yes, so it looked like 50% of the audience do it in weeks, 31% longer, and most of the responses are 54% with not currently available.
All right, okay, interesting stuff. Okay, thank you very much. So looking at the different levels of maturity, there's a level of effort required and an associated impact, and there's kind of 3 levels beyond the baselining. So as I mentioned, changing the location can reduce the carbon emissions, but you're not having to make any design changes and no material changes. Then changing the manufacturing process, you might be able to get away with that depending on the design. Depending on how much has been invested in tooling, things like that. You might be able to change the material or some minimal design changes. And then starting from design means you do have a holistic approach where you can change everything. And you can see on the chart there, the earlier that you start, the more potential you have to reduce the carbon emissions. And it's very analogous to cost. So you've probably seen this before. And aPriori knows cost very well. We've been doing it a very long time. And CO2 is very analogous to this. So at the start of a project, you've got lots of design freedom. Nothing's really set in stone. So you can make design changes in Creo really, really quickly. And there's no real cost to it. It's just the time. And as you get closer to product launch, more things are kind of locked in. They're set in stone. We don't want to change them, and there's a knock-on effect. So the cost of any design changes goes up the later it is, and that is exactly the same for CO2 reduction potential as well. So when we start with design for sustainability, there's a number of different ways you can assess it. So a life cycle assessment, an LCA tool, you're probably using them, or at least someone in your company is probably using them today. They really assess everything from cradle to grave. So extraction of the raw materials, the logistics to the manufacturing facility, and any refinement that goes on in between. Then transportation to where it's used, to the customers, to where it's purchased from, things like that. And then how is it disposed of? What happens at the end of life? Is it recycled? Is it reused? Do we take some and remanufacture it? Or does it go to landfill, or is it incinerated? And if you look at a circular design strategy, that's not really looking at reducing carbon emissions. That's more looking at capturing the resources that are used, reusing the material. And so you can lead to this cradle to cradle and have a perfect cycle. But in reality, it's never really perfect, because there's always some leakage in that circularity, because you're kind of relying on the users, the consumers, to return the products to you so that you can fully utilize it. So there's always some leakage. So really, cradle to gate is where design and manufacturers can have the most influence, because they're not reliant on the user, the consumer, doing anything in particular. So that's a really good place to focus, and that's where we help as well. But it's really not very straightforward. It's not intuitive. And the next question is really, which of these processes do you think would lead to a lower product carbon emissions from the manufacturing phase? So we're not looking at the weight or any energy use while it's out being used by the consumer. But if we look at raw material extraction through to manufacturing, cradle to gate, what would you say is going to lead to the lowest product carbon emissions? And one of the poll questions refers to this slide. So if you could just take a look at that question.
I think we had 67% of answering casting, actually.
Oh, okay. Oh, excellent. Right. So I said it wasn't that intuitive, but obviously you do know the answer, because yeah, in actuality, it does lead to a lower embodied carbon for the same design if we were looking at both. And that's really because we're looking at the amount of material emissions. So the raw material extraction and the refinement of those materials is what makes the difference, and also the wastage. Because we're having to buy a certain amount of material to manufacture the product, we really need to consider that amount of material. And machining's got a lot more waste in the process. Now, usually the next question that comes up is, well, what if we reuse those chips or recycle them or anything? Well, we can't actually benefit from that recycling in this product, so we have to consider them as waste. But if we were to use that recycled content, that's now got a lower carbon equivalent emissions, because it's already been used effectively. We've already accounted for the carbon emissions as waste, so the recycled content is a lot lower. So just to break this down a bit further, and these are results that we found from aPriori, you can see the process emissions are actually slightly higher with die casting, because it's a lot more energy intensive melting the material. Much more lower process emissions from machining, but it's the machining, the material emissions that really make the difference. And aPriori gives you a percentage of material utilization as well. So you can see the finished mass, which is usually what gets used in the life cycle assessment, because that's all that's available. That's just taking the CAD model and getting the mass from the CAD model. But that's not the true amount of material that you need to manufacture it. And so that with aPriori's calculation, we can actually determine the rough mass from the CAD model, and then you get to a more accurate material utilization value and embodied carbon. So that's for casting and machining. But what about a plastic part, a polymer part, for example? So same kind of thing. If you take the same design, and you look at different materials, this is another approach that you might want to use. And aPriori comes preloaded with eco-invent data. So if you haven't got primary data from suppliers about how much carbon is in your materials, eco-invent's a really good source to augment that. So if we look at these different materials, if we were to start with a nylon type 6 product, we've got a price for a kilogram of that material is $4.66, and the equivalent and the amount of carbon equivalent emissions from that material is just over 9 kilograms of carbon per kilogram of material. So you might look at what other materials are available and their corresponding amounts, and usually you'll find those per kilogram. So you can look at the cost per kilogram and the carbon per kilogram. So you might go, oh, a type 6 with 30% glass looks like it's a good option because it's lower carbon and lower cost as well, very slightly. But it's more dense. It's a more dense material, so that's when it starts to get really complicated. But we could go for that option, and there's a few others. So if we do go and look at analysing the same part with nylon type 6, the material, because of the density is about 17% more dense. So you actually end up with a heavier part for the same amount of same volume for the same design, and it's actually more expensive as well. However, the cooling time with the glass fill is much reduced. So the overall embodied carbon is reduced by going for a more carbon intensive material and more expensive material. You're actually lowering the cost and lowering the carbon because of that cooling time. And that's where aPriori really comes into play, because we look at all of that in a lot of detail. We're actually simulating how long it takes to injection mold the parts or manufacture the parts and machining, for example, and give a really good, really precise comparison between the two. Whereas an LCA tool is not going to give you that level of granularity and detail. So yeah, one thing that LCAs just overlook is cycle time, because you've got overheads in the factory that are all using energy as well. So being able to look at the cycle time is a big driver of the process emissions. So here we managed to reduce 60% of the cycle time, which led to about a 10% drop in carbon emissions just by changing that material. But we would never intuitively do that because, as I said, it's a more carbon intensive and more expensive material. And then if you look at that further, if we go to a nylon with 30% glass, it's a stiffer material. So we could actually look at reducing the wall thickness. So that's going to lead to further cycle time reduction and material reduction. So that 17% density increase could be mitigated. Just depends on doing an FEA analysis just to check. So that's how we can break it down in aPriori. We can look at the labour costs, material cost, and all of the process costs that are associated with it. So it's nice to find these little win-win examples, and then obviously we can simulate it again with a thinner wall section and thinner sidewalls and things like that to reduce further. So I mentioned LCA a few times, and the question in the poll about how long does it take to get results was really aimed at this question, because LCAs are very good at creating reports, so you can produce something along with your product and say what the environmental impact is, and they do cover from cradle to grave, which is great, but they do take a long time. They're very manual and they make a lot of assumptions, so they're not great at really giving us the insights to make design decisions, and because they take too long as well, you normally need to have it all finished before you can start to do an LCA. And so if we look at the difference between kind of aPriori to calculate carbon emissions and LCA, there's two very distinct sections within or parts within a product's life cycle. So the first 4 chevrons, first 4 boxes you can see on there, that's really where the designer is having a lot of influence, or the manufacturer is having a lot of influence. You know, where is it located? Where is it going to be manufactured? What's the shape? How thick are the walls? What's the process and what's the material? So that's cradle to gate. And that's where we can give instant results, instant feedback, so you can make the right data-driven design decisions around not only sustainability but profitability as well, because we give you a cost figure. Now, everything else, when the product leaves the factory gate, that's where you've got to make a lot of assumptions. You can't account for every single product individually, because they're all traveling different distances, so you can't really say each logistics for each product. You have to make an assumption, you have to make an average. Then the in-use phase, if you take a high-end sports car, for example, some people are just going to leave it in the garage for its whole life. Other people are going to drive it hundreds of thousands of miles. So you've got to make another assumption, you've got to use averages. So that really lends itself quite well to an LCA tool. But where you've got a very precise manufacturing process that's repeatable, it's the same for every product that leaves your factory or your supplier, you can afford a more precise calculation, and using manufacturing simulation is a really good way to do that. Then the end of life, as I mentioned, there's leakage in the circularity. Unless you've got a really perfect kind of subscription model where the product's returned to you, or product as a service kind of a business model, it's very unlikely that you can ensure that 100% is remanufactured or reused or I guess worst case recycled. It could end up in landfill. If we use the sports car example, bottom of a lake, inside a wall, something like that. So you can't really, you can kind of incentivize what happens at the end of its life, but there's leakage in that circularity. So if you want to focus on, you know, what makes sense from a designer and manufacturer, we can give you that real-time insights into what to change. And so yeah, opportunities that we can bring with aPriori. We closely work with PTC, so we plug into Creo, plug into Windchill, so you've got that continuous digital thread between all of those products. And we've got analytics as well, so everything you run through aPriori, the results can go into Windchill, but we can also view them in our analytics. So it helps to identify where you've got opportunities to move certain products to low cost and low carbon suppliers based on their location. And you can look at different design specifications and different materials as soon as you're designing it while you're still in Creo or Onshape. And you can also look at changing the manufacturing process. So do you use anodizing or powder coating? What's the correct order? What's the most efficient order of the different manufacturing processes? If you've got casting, then machining, and other processes after that, aPriori will optimize that process for you. But more than that, just like we do with cost, we break down every single process and the material, everything that goes into manufacturing the component. We'll break that down for carbon emissions and for cost. So if you've got a particular process that's really high in cost or really high in carbon, you can look to mitigate that process in a number of different ways. And we just published a white paper actually, so if you're interested in learning a bit more, just new on our website is a new white paper all about sustainability and how manufacturers can reduce that. So if you want to take a quick grab of that QR code, have a look at our white paper. And with that, I'll take any questions. If you've got any more, you can reach us at hello@apriori.com. But happy to take any questions.
Thanks a lot, Mark, for sharing all these interesting insights here. And actually, the first question goes to you, Paul. So, I mean, Paul, now when we have heard great things about aPriori on their offerings and how they actually impact sustainability, Can you please comment on how the digital thread provides scope for impact across the broader product lifecycle?
Yeah, thanks, Torbjørn. Great question. So I think certainly the digital thread supports that overall cradle-to-cradle approach that Mark mentioned in his presentation earlier. I think fully implemented, that digital thread and the capabilities that we have. And Mark, perhaps if you just go to the next slide, there should be one embedded in here, which sort of talks a little bit about these, how additional capabilities around the digital thread can have an influence across all of the phases of the product's life. And as you can see on this slide, we've sort of split this into the beginning of life, middle of life, and end of life. What we've seen with Mark's presentation and the great work that aPriori are doing is focused on that beginning of life phase. And I think that carbon debt visibility that you can just see there on the left-hand side, that's what we're talking about with aPriori, that carbon debt visibility, using the EcoInvent database to provide that sort of point of use visibility to the impact that's being created. Of course, it links to procurement, which is just along from that capability. I think you've got the idea that if your procurement organization understand, again, linking back to one of Mark's examples earlier, is the steel you're using in your product, has it been created in a old coke-fired blast furnace versus an electric arc furnace? Because the electric arc carries far less carbon debt with it. So you've got things like that carbon debt visibility in the procurement piece, but then the digital thread has a influence that goes into the factory. We see a lot of Industry 4 and smart factory initiatives aimed at reducing scrap and rework. And of course, if you're not making mistakes down on the shop floor, you're not embedding quite as much CO2 debt into your manufacturing process. And then perhaps if we just take a very quick look at the middle of life, this is where we're trying to help our customers using the digital thread maximize the life of their product. And they do that, some of them through advisory services, for example, where customers are keeping products running longer with the customer, making the most efficient use of that product from an energy consumption perspective and so forth. And we've got, like I said, many companies doing that as part of a connected product strategy, using an IoT platform to deliver that. And then end of life. End of life is all about making sure that we can drive that circular approach to the way in which the product is managed. And that, again, is partially delivered and helped by the digital thread. So again, we have a number of customers using PLM, using our windshield technologies to embed information, even in the design phase, about what happens to that product or that subassembly or that particular module of the product. What happens to it when it reaches its end of life? So the service technician can understand, as Mark mentioned, this goes back to the factory to be reconditioned, to be remanufactured, whatever it may be. So all of these technologies, I think, all have a role to play in this idea of a digital thread helping on sustainability and circular economy topics. So hopefully, Torbjørn, that's given a quick flavor for how we can use a digital thread, started absolutely with the type of information that aPriori deliver, but also extending that into, all aspects of the product's life.
Definitely. Thanks a lot, Paul, for the good overview here. And I think we are also having quite a lot of questions coming up in the chat here. So I will actually go to one of them, and that is from Lonkar. Can the results from aPriori be used directly for APD certifications and declarations?
Yes, it's a great question. So yeah, one of our customers, one of the early adopters of our tool over a year ago, Carrier, they do HVAC equipment, among other things. They're also a PTC customer. They've identified a huge saving because they were using a third party for their environmental product declarations, and there's huge cost to get consultants to use those. They've identified that it would be possible to use aPriori to do that. It's very auditable. All of the numbers in our calculations in our engine are very transparent. So for an auditability standpoint, you can show exactly what calculations are being used, what numbers, what's being drawn from the CAD model and what's from the EcoInvent database or your own sources, things like that. So yeah, absolutely, there's a huge opportunity to do that.
Thanks a lot. And one other question from Alexi is around, I mean, can aPriori data be exported, for example, in Excel to be further used in more extensive LCAs or other meterings? Does it grant access to the data sets you are linking your materials and access to, or?
It does, yeah. At any point in time, yeah, you can download an Excel spreadsheet with all of the data that's been used to calculate it. Yeah, so cycle times, rough mass, finished mass, all of that is available. So yeah, in Excel format.
All right, thank you. Another question also from Nituri. Is there a library available within aPriori kit to link machine process to CO2 emission for a particular machine operation in BOP?
It is, yes. So we do actually have a full library of machines and the associated power consumption of each of those. And we're not just using an average, we're looking at simulating what kind of machining strategies we're using on particular machines and the associated energy consumption for each type of machining process. So super precise level of detail. So yeah, we've got overhead rates and overhead consumption in terms of the energy mix in that level, in that region, the specific machines that are available, and it's all configurable as well. So if you, the idea is you create a digital twin of your manufacturing facility or a supplier's manufacturing facility. So if they haven't got a 5-axis CNC machine, you just take that out of the digital factory and then it will try to manufacture the same part using a 4-axis machine with some rotation of the part and things like that. So it will give you a digital twin of the manufacturing process, and that can be obviously it will give you the precise CO2 emissions from however it's actually manufactured.
Thanks a lot, Mark. I will take a last question here, and that is from Kamlesh Patil. Are there any videos to see aPriori in action with Creo on Windchill, or is also, I mean, aPriori compatible with Windchill Plus? And where can I see the Windchill Creo and aPriori products compatibility matrix, if possible?
It's a good question. Yeah, so we do have a number of videos that we can share. I've got one to hand, which is just a very high level 2-minute video that I can put a link in the chat for, if that's okay.
Perfect.
And that's got Creo in it, and it mentions Windchill. Is Windchill Plus the cloud version?
It is, Mark. Yes, yeah. And I mean, we're doing the same things in Windchill Plus as we would be doing on an on-premise Windchill. So the answer to that question is yes. You know, whatever you've got in Creo is then going to be compatible with an on-premise or cloud version of Windchill. No problem.
Excellent. Yeah, I'm pretty sure that's what we use for our demonstrations and things.
Yeah.
It's all in a web browser.
Thanks.
Yeah.
Guys, time is unfortunately running out, so many thanks for everyone for joining this session here, and special thanks to you, Mark and Paul, for all your good insights. So with that, I hope to see you back for the next week's PTC Talks on the 7th of June for a session about making product design manufacturable by aPriori again. So stay tuned for that and have a fantastic weekend, everyone. Take care. See you next week.
Thanks all.
Thank you.
Bye.